when I turn on the slide switch, the color LED comes on and it's pretty bright, but the speaker is relatively quiet. Now note that the color LED is bright on only a limited range of settings on the adjustable resistor. But when I push the press switch, the color LED dims, but the speaker becomes louder. That's because the pushing down the press switch causes the Q2 transistor to act as an amplifier that makes the speaker louder, but it also draws current from the color LED, making it dimmer. When I turn on the slide switch, you're going to hear a tone that is controlled by the color LED. Listen. And the speaker beeps as the color LED changes colors. Now you can override the tones by pushing the keys. And what's interesting is that as the color LED changes colors, it actually turns off briefly, producing the sounds that you hear. And the Q2 transistor acts as an amplifier. When I remove the R3 resistor, you will only hear sound when you push the keys. But the color LED still controls the sound effects through the Q2 transistor. I inserted the photoresistor, and when I shine light on it, you hear a combination of unusual sounds as the color LED changes colors and flashes. Once again, the Q2 transistor, the color LED uses the Q2 transistor to control the sounds on the keyboard, but you can wave your hand over the photoresistor to change the sound effects as well as push keys. And there you have it. With this version of the LED keyboard, you can use the adjustable resistor to control the tone and pitch of the sounds. And you can still push the keys for further effects. Here you have much higher pitch sounds. They may remind you of alien-like sound effects from a science fiction movie. I've included the C7 capacitor, which will further change the range of tones available by the keyboard. There's too many combinations of sounds for me to show. Some of them may remind you of music from an old-fashioned video game. And then, for the next project, I will replace the C7 capacitor with the C2 one. And you'll notice that the sounds are different. Here, you can not only push keys to produce sounds, but you can also talk into the microphone. You can make the sounds echo. The adjustable resistor is, the RV adjustable resistor is used to control how much the sounds echo, while the RV3 adjustable resistor controls the volume. I'm going to push keys, and you can hear the different tones from the speaker. You can adjust the RV lever to make the echoes faster. And then I'm going to talk into the microphone. Old MacDonald had a farm, E-I-E-I-O. My voice isn't very loud, but the sound from my voice is not very loud on the speaker, but you gotta get the idea. And the reason why the speaker is attached to the circuit by jumper wires is because the circuit may self-oscillate due to feedback if the speaker were directly connected to the circuit. This project is similar to the previous one, except I now include the color LED, and when I push keys on the keyboard, the color LED blinks. Now you can't control the volume on this circuit either, but you can still talk into the microphone. A, B, C, D, E, F, G. I'm not going to sing the whole song, but you could hear my voice echo on the speaker a little better. You might have to talk loud into the microphone to hear the sound echoing on the speaker. And again, it has to be connected to the circuit by the jumper wires, because otherwise the circuit may self-oscillate because of feedback. I replaced the microphone with the photoresistor, and I'm going to shine a light on it and hear the sounds now. They kind of sound like a violin. You can adjust the amount of light either by waving the light source over the photoresistor or waving your fingers in between the light and the sensor, and you can pretend that you're playing the violin. And of course you can control the echo using the RV adjustable resistor and by pushing keys on the keyboard. The sound is louder when there is more light on the photoresistor. Now I'm going to go directly to Project 9-Day, where you would remove the adjustable resistor, and now there's no echo at all. The sound produced when light is shining on the photoresistor may remind you of that of another instrument like a synthesizer. But it still sounds a lot like a violin or other string instrument. This is an audio light that will come on when there is darkness. I shine the flashlight on the photoresistor and the LED and sound are off. But when I cover the photoresistor, the color LED turns on, and although it's not very loud, you can hear sound coming from the speaker. But again, when I shine enough light on the photoresistor, the LED turns off. The RV3 adjustable resistor controls how sensitive the photoresistor is to light. This is an oscillator. An oscillator is a circuit that produces a repetitive electrical signal on its own. In this case, it will produce a sound that turns on and off at an incredibly high rate of speed. You won't be able to notice it with your ears, But once again, the sound is turning on and off many times a second. The C2 capacitor is what's controlling the oscillator in this particular circuit. Now the next 5 projects are variants of the oscillator. For the next project, I'm going to replace the C2 capacitor with the C7 one. And the sound is much lower in pitch. With any of these variants, you can push keys on the keyboard, but the circuit will spontaneously produce a sound of its own. Replace the C7 capacitor with the C5 one. And now you only hear a click every couple seconds. Changing the capacitor changes the frequency. I will replace the R3 resistor with the R1. Now you'll hear several clicks a second. Replace the C5 capacitor with the C7 one. Now it's much higher pitch. Finally, I'm going to replace the C7 capacitor with the C2 one again. Now the tone is extremely high pitched and the frequency may be too high for your ears to hear, although I personally can hear it. Can you? Now when I remove the capacitor from the circuit completely, you hear an even higher frequency and you won't hear it at all. However, some animals like dogs who have much better hearing than people might hear and react to it. And there you have it with oscillators. This is called the left-right bright light. And you'll know why in a second. The adjustable resistor is on the middle setting, and the color LED, as you might tell, is not very bright. However, when I move the adjustable resistor lever either to the very left or to the very right, the LED is much brighter, kind of like a seesaw. Back in the middle, it's dimmer.